For as long as human beings have looked up at the night sky, the moon has been a symbol of mystery, rhythm, and beauty. It has guided sailors across oceans, inspired poets and artists, shaped calendars, and influenced cultures across civilizations. Yet, on certain nights, something extraordinary happens. The bright full moon begins to dim. A shadow slowly covers its surface. The glowing white disk turns deep copper, sometimes even red. This phenomenon is known as a lunar eclipse, or Chandra Grahan. A lunar eclipse occurs when the Earth moves directly between the sun and the moon, blocking the sunlight that normally illuminates the moon. The moon does not produce its own light. It shines because it reflects sunlight. When Earth interrupts this light, its shadow falls upon the moon. What we witness in the sky is not the moon changing, but Earth casting its shadow into space. To understand this event fully, we must first understand the relationship between the sun, Earth, and moon. The moon orbits Earth approximately once every 27 days. At the same time, Earth orbits the sun. A lunar eclipse can only happen during a full moon, when the moon is positioned on the opposite side of Earth from the sun. However, eclipses do not occur every month because the moon's orbit is slightly tilted relative to Earth's orbit around the sun. Only when all three bodies align in a nearly perfect straight line does a lunar eclipse take place. Earth's shadow has two main parts. The outer, lighter shadow is called the penumbra. The inner, darker shadow is known as the umbra. When the moon passes through the penumbra, the dimming is subtle and often difficult to notice. This is called a penumbral lunar eclipse. When part of the moon enters the umbra, a partial lunar eclipse occurs, and a visible dark portion appears on the moon's surface. When the entire moon moves completely into the umbra, we witness a total lunar eclipse. During a total lunar eclipse, something remarkable happens. Instead of disappearing into darkness, the moon turns red. This is why total lunar eclipses are sometimes called blood moons. The red color is not random. It is the result of Earth's atmosphere bending and filtering sunlight. As sunlight passes through the edges of Earth's atmosphere, shorter blue wavelengths scatter away, while longer red wavelengths bend inward and reach the moon. In essence, every sunrise and sunset happening around Earth at that moment contributes to painting the moon red. This reddish glow can vary in brightness and shade. Sometimes the moon appears bright copper. Other times it may look dark and brownish. The exact color depends on the condition of Earth's atmosphere. Dust, pollution, or volcanic particles can make the eclipse appear darker. In this way, lunar eclipses even provide scientists with clues about atmospheric conditions. Unlike solar eclipses, lunar eclipses are completely safe to observe with the naked eye. There is no need for protective glasses or special equipment. Anyone on the night side of Earth, where the moon is visible, can witness the event. This accessibility has made lunar eclipses one of the most widely observed astronomical phenomena throughout history. Ancient civilizations often interpreted lunar eclipses as powerful omens. In Indian mythology, the story of Rahu and Ketu explains the eclipse as a cosmic event involving a celestial being swallowing the moon. In Chinese folklore, people once believed that a dragon devoured the moon during an eclipse. In other cultures, eclipses were seen as warnings, signs of transformation, or moments of spiritual significance. Today, modern astronomy provides precise explanations and predictions. Scientists can calculate eclipses hundreds of years into the future using mathematical models and orbital mechanics. The alignment required for a lunar eclipse is known as syzygy, a term describing three celestial bodies arranged in a straight line. This alignment reveals the predictable and mathematical nature of what once seemed mysterious and supernatural. A total lunar eclipse can last for several hours from beginning to end, with totality, the phase when the moon is fully within Earth's umbra, lasting up to nearly 2 hours. The slow progression gives observers time to reflect and appreciate the gradual transformation. The moon's surface features remain visible even during totality, glowing softly in red light. Lunar eclipses have also contributed to scientific discovery. In ancient Greece, the philosopher Aristotle observed that Earth's shadow on the moon was always round during eclipses. From this observation, he concluded that Earth must be spherical. Centuries later, eclipses continue to provide opportunities for scientific study, including measurements of the moon's distance and analysis of atmospheric composition. Beyond science and mythology, a lunar eclipse carries symbolic meaning. It represents cycles, light interrupted by shadow, only to return again. It reminds us that darkness is temporary and part of a natural process. The moon does not vanish forever. It emerges from the shadow as bright as before. For many people, lunar eclipses are moments of quiet reflection. Watching the Earth's shadow slowly move across the moon connects us to the vast scale of the universe. It reminds us that we are part of a cosmic system governed by gravity, motion, and time. The event unfolds silently, without sound, yet it carries profound impact. Photographers and astronomers often prepare carefully to capture the stages of an eclipse. Using telescopes, cameras, and time-lapse techniques, they document the changing colors and shadows. These images not only showcase beauty, but also serve educational purposes, helping others understand the mechanics behind the event. One of the most poetic aspects of a lunar eclipse is the realization that what we are seeing is our own planet's shadow projected onto the moon. It is a rare opportunity to witness Earth's presence in space from a different perspective. The shadow itself becomes visible, revealing the shape and scale of our world. As technology advances and light pollution increases in cities, moments like lunar eclipses encourage people to look up again. They remind us that beyond our daily routines, there exists a universe filled with predictable yet awe-inspiring phenomena. From ancient fears to modern fascination, the lunar eclipse has traveled through human history as both a scientific event and a cultural symbol. It bridges mythology and astronomy, belief and evidence, tradition and discovery. When the shadow finally passes and the moon regains its full brightness, we are left with a sense of completion. The cycle has unfolded exactly as physics predicted. The sky returns to normal, yet those who witness the eclipse carry a renewed appreciation for the harmony of celestial motion. A lunar eclipse is more than just an astronomical alignment. It is a reminder that we live on a moving planet, orbiting a star, accompanied by a natural satellite, all part of an intricate cosmic dance that continues whether we look up or not. And perhaps that is the true beauty of Chandra Grahan. It is both ordinary and extraordinary at the same time.